Math Fact Match. This game is one that came out of a need to add some interest in just practicing multiplication and factors. I use it in my tutoring sessions with kids who can complete a multiplication table without mistakes. Its purpose is to help connect the different factors that generate the exact same product. It could be done with other operations, but I find that multiplication is the one that is most needed. Here's how the game works. So you've got two players. You could have three or more players. So player one scans the array. So I've actually made a set of these on index cards that I cut in half, and I just wrote on them with a pen. Don't use marker because some of the cards you can see through it. But I wrote on them with a pen, the fact on one side, and then the factors on one side and the products on the other side. And I lay them out in an array. Usually an 8x5 array, but I go bigger if they are just learning how to play the game. And I usually start out with factors that are 10 or less. You have fewer matches, but you will have the commutative match. And you'll see what I mean by that in just a moment. So player one scans the array and they decide on what factor they want to do. Player one sees that there's several factors that equal 6. So the first one, they turn the fact over and they leave it there. And then they turn another fact over and they're like, okay, so those two. But there are other factors on the board that equal 6. And you can take all of them if you know what they are. So here's one in the corner that is 1 times 6, and it's also 6. And let's say that player one then doesn't see another 6 out there, so they call their turn over. They take those facts and put them in their stack, and then those facts are replaced with others. Player two now has their turn. And the first move on their turn, they can take any 6s that player one missed as their own, and it doesn't count as their turn. So they basically get a bonus card. So player two sees 6 times 1. They turn it over, it's 6, they automatically put it in their stack, and then they take their turn. So I didn't animate that. That was a lot of animation in that one. But here's what you need, the skills that you need in order to be successful at this game. This game is played after a student can complete a multiplication chart without assistance and with no mistakes. So one such as this one. This one is a 1 through 12 multiplication chart. You can also do it with a 1 through 10. With the multiplication chart complete, we start out by examining the multiplication chart before I play the game. So this is kind of an intro to the game, and we will often repeat this exercise. So a student has written this chart out by hand. I never give them one that's already completed for them. If we do a multiplication chart, they are the one that completes it, because the more they do that, the better they get at it. Then I have them gather a few colored pencils, and then I ask students to find products on there that happen more than once. And most of the time they will see the number 4 first. I'm not sure why, because the 2s are right there by the corner. And then I point out to them, are those the only 4s that are on the board? And no, there's a third one. So they shade all those in. And then I have them find another one, because the factor that occurs on this board the most occurs 6 times. And there's actually 2 of them that occur 6 times. And that is 12. And we also talk about the commutative version. So there's 1 times 12 in the upper right corner, but in the lower left corner, there's 12 times 1. And they both equal 12. Well, then there's other ways to make 12, because you have 6 times 2, 2 times 6, 3 times 4, and 4 times 3. So 12 is actually on there 6 times. So if you're looking at an array on this game and you see a factor that equals 12, then you quite possibly could get 6 cards in your turn. There's another one though, it's 24. And of course, if your multiplication array were bigger and went all the way out to 24, you would have more. But we're limited in our space. So we're just saying how many factors are on this board, not how many factors are of this number. And then we take a look at other patterns, and there are many, many patterns on this board that are fun to explore and allowing the kids to see those patterns. Things like the ones that go down the diagonal are your square numbers. And then you have your prime numbers that are only along the edge where the one is. And then you'll notice that 1 is the only number on there that doesn't have a match. And then you can talk about those such things. I also include discussions about factors and multiples and the connections between the two. So for instance, 6 times 1 is 6. That's a multiplication fact. But what's a factor? What's a multiple? There are 2 factors here, 1 and a 6. And there is only one product or multiple. And then I also emphasize that a product and a multiple is the same thing. Then we examine, well, there are other ways to make 6. So we take a look at those other ways. There's 2 times 3, which is 6. Are there any other ways? Not with different numbers. So then you can say that the number 6 has 4 factors. And that's 1, 2, 3, and 6. And if you're in the higher grade, you can talk about decimal multiplications too, but those are not factors because they're not whole numbers. Then you can talk about commutative properties. So if you have 2 times 3 is 6, then you also have 3 times 2 is 6. And if you have 1 times 6 is 6, then you also have 6 times 1 is 6. And I want you to notice when you put these in this order, what you should notice, and what I always pointed out to my students, as the first factor gets bigger, the second factor gets smaller. And then we start talking about those relationships. If the first factor gets bigger and the second factor gets smaller, and your whole goal is to make a 6, the discussion should lead to that has to be true. You can't have both factors getting bigger and you get the exact same product. Then we continue the discussion in a little bit different order with a number that's got more factors. I can say 1 times 12 is 12, but then I can also say 12 times 1 is 12. So 1 and 12 are both factors no matter what order they're in. I can say 2 times 6 is 12. I can also say 6 times 2 is 12. I can say 3 times 4 is 12, but I can also say 4 times 3 is 12. And if you look at that, even though the commutative ones are in a different arrangement, they have the same 6 numbers. 12 has 6 factors. So now as you look at our array again, the arrangement of these cards, just have your kids take a few minutes to glance over it. A lot of times kids don't want to sit and think for a bit, so you have to let them know that sometimes you're going to have to think. And when it's not their turn, I encourage them to continually look at the cards and think about what those answers are. So if you're like, okay, there's a 2 times 4 in the upper right corner. What does that equal? That equals 8. And I would walk this through them first time I lay out the game. I'd be like, hey, look at that. There's a 2 times 4. What's that equal? And, 8. Well, I want you to look over the board and see if there's any other numbers or any other ways to make 8. And they might want to point at it and stuff, and that's okay. As you progress through this game, it becomes more and more in their head because they realize if they're pointing, they might be giving it away to their opponent. Or if you've got 3 people playing, they might be giving it away to the person who has the turn right before them, and then they won't get their turn. There is a couple of numbers in the stack, just like on the board, that will have only one fact in there. And that's 1 times 1, 5 times 5, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, and 12 times 12. So those are all special cards that you don't have to have a match to. And they have to know that. So for instance, 1 times 1, you can pick it up, not need a match to it because it's the only one out there. Could you do that with 2 times 2? No, because there's also 1 times 4. So there are other ways to make 4. So 2 times 2 has to be picked up with at least 1 times 4 or 4 times 1. Well, what if 1 times 4 is out there? As you can see on the board, it's over on the right, but 4 times 1 isn't, which actually 4 times 1 is. But let's say it wasn't. Well, you can pick up the 2 times 2 and the 1 times 4, but then the 4 times 1 doesn't have a match. So it just kind of becomes a dead card, and it's just there taking up space because nobody can pick it up because its matches have already been done. Some people, I made up this game. You can modify the rules and say, well, in the future, if you already have the 2 times 2 and the 4 times 1, You can collect that, or if you already have the 2 times 2 and the 1 times 4, and then later in the game 4 times 1 comes up, you can just add that on your turn to your 2 times 2 and 4 times 1 and 1 times 4 until you have them all. But that becomes your turn. So there are all kinds of ways you can sort of change the rules or modify the rules to fit what goal it is that you're trying to do. Here are some things to consider when you're playing this game. First of all, the more you play the game, the more your students remember their factors and multiple connections, and it becomes more competitive. It can be quite slow and dragging at first, so you might have to give them some prompts or give them some hints, which is why I allow them to use a multiplication chart the first few times that we play. Next, if a student doesn't know their facts well enough, the game can get really complicated, and it really will complicate their learning. So make sure they have their facts done first. You can put time limits on turns, especially if you have kids who have played several times and are really getting pretty good at it. You can say, all right, you've got 60 seconds to make your choice. That way they have to have it in mind before their turn which card they're going to take. If they turn over a card and they think that another card is its match and they turn it over and it's not its match, those cards get turned back over and they lose their turn. So if they've accidentally picked up a match that doesn't match, those cards stay on the playing field, turned back over, and they just lose their turn. Students who are first learning this, I do let them use their multiplication table to study when it's not their turn. I also, when it is the very first time, I let them use it on their turn. And then you progress. They can look at it when it's not their turn, but then when it is their turn, they have to turn it over and do their moves. And then once you're done this several times, you can just have them make out a multiplication table, look it over before they start, and then have them play the rest of the game without it. As with most of my games, there's all kinds of modifications that you can do. You can actually, when they first start, you can have them use a multiplication table to mark off the products that have been taken. That can really help students, especially when they're learning how to work with the multiplication table. Next, the last part of a person's turn could be changed so that once they've gotten all their facts, their last move is to turn over their opponent's first card. So then your opponent has to match that card. The only thing with that is you have to make sure that it actually does have a match. Otherwise, they would lose their turn every time. So that one I'm still toying with. I haven't really got that one refined. To advance the difficulty level, have the students add the 11s through the 15s cards. So I keep my cards in a separated deck. I'll have my 1 through 6s in a stack, and all the factors in that stack are either 1, 2, 3, 4, 5, or 6. And then I'll have a stack that is 7s through 10s. And it's like any card in that stack, either the highest number on that card for factors is 10. And then I have a 11 and 12 stack that I will add in as the game progresses. So once cards are taken off the board, I flip over new cards to fill in the holes. Once the 1 through 6's stack is gone, I start filling in with the 7 through 10's stack. Once that stack is gone, you can go to 11s and 12s, depending on the level of your students. My cards are made with point value symbols on the underside. So for instance, this is one of my cards. Simple card, index card, cut in half. I wrote 10 times 1. And on the back is its product, 10. And notice the little dot in the corner. That gives its secret point value, which I then have this scorecard. The single orange dot is 100 points. There are some dots inside a circle, and those are worth 500 points. Green X's are 50 points. Blue squiggles are 20. Purple pluses are 10 points. If the card has no symbol, then it's worth 0 points. I started out with a bunch of 0-point cards, and I ended up adding several cards because once somebody got a 500-point card, it was really difficult for them to for the other people to catch up. So I added a bunch more 500-point cards and a bunch more 100-point cards. So it's really anybody's game. So these are what my cards look like. Pencil on one side. Actually, I think it's pen. And then some sort of a symbol that I drew on the other side. And 5 times 4. Ooh, there's another symbol. There's the green X. And at the end of the game, once the game is over, however you decide to end it, either by time or you ran out of like the 1 through 6 stack of cards and there's no more matches, then the game is over and the kids start to total up their points. This is where they get mental math addition practice. Or you can let them have a piece of paper and write it out, but they are practicing adding. And that's when we discuss things like making groups that are easy to add. So like if you have a 50-point card and a 50-point card, that's 100. So you make little stacks of hundreds to help you to count your numbers easier rather than writing, because they're likely to have stacks that are about this big. Rather than writing all those point values out and trying to stack it and do that algorithm, that's hard and it takes time. There's a lot more efficient ways to add, and this gives you an opportunity to discuss those more efficient ways to add. Thanks for watching today. I hope you enjoy playing my game, and please make any modifications that you want and drop a note in the comments to let me know how it went or what you changed or how you made it better, because any game, you can make a game of numbers out of just about anything. You just got to make up the rules. So let me know how it worked out for you. Thanks for watching. I'll see you in class.